Hi guys, let's look at the next question in this exercise 21C. It says length of each side of a cube is increased by 3 centimeter, then the volume increases by 2457 centimeter cube. Find the side. Okay, so let the original length of cube be x centimeter. So the original length is x centimeter and new length is equal to x plus 3 centimeter because it's being increased by 3 centimeter. They're saying when it's done, the new volume is more than the old volume by 2457. So which means new volume is equal to old volume plus 2457 centimeter cube. Let's put the formula, whatever we know. We know the formula of volume of a cube is h cube or length cube. In this case, x plus 3 whole cube is equal to old volume, which is x cube plus 2457. If I remember the expansion of this is x plus y whole cube. That's x cube plus y cube, in this case 3 cube, that will be 27, plus 3xy, in this case 3 multiplied with the first term multiplied with the second term multiplied with x plus 3, which is equal to x cube plus 2457. X cube and x cube on these two sides gets cancelled, and I am left with 27 plus 9x times x plus 3 is equal to 2457, which means 9x square plus 27x plus 27 minus 2457 is equal to 0. Looks like a quadratic to me, and then we'll have to solve this quadratic. So this would be 9x square plus 27x plus 2457 minus 27, that's 30. So this is not plus, minus 2430 is equal to 0. I notice this is 9, this is also 9 divisible by 9, 4729 divisible by 9, which means dividing both sides by 9, I get x square plus 3x minus 9 into 2, 18, that's 63, 9 sevens are 63 is equal to 0. I need to find factors of 270, the sum of which will be 3. So 272, that's 135, 3, that's 45, 3, 15, 3, 5, 5, 1. That's 6, no, 9, no, 18, yes, 18 into 15. Perfect. So this is x square minus 15x plus 18x minus 270 is equal to 0. X times x minus 15 plus 18 times x minus 15 is equal to 0, which means x minus 15 times x plus 18 is equal to 0, which means x is equal to 15 or x is equal to negative 18. Now since length cannot be negative, therefore x is equal to 15 centimeter. Therefore original length is equal to 15 centimeter. Perfect. Let's look at the second part. The second part says how much will the volume decrease when each side is reduced by 20%. So now new length is equal to reduced by 20%, which means 80% of the original, which is 15 centimeter, which means 80 upon 100 into 15, 20 into 4, 20 into 5, 5, 1, 5, 3. This is 12 centimeter. So we need to figure out what is the decrease in volume. So decrease in volume will be equal to old volume, in this case 15 cube, minus new volume, which is 12 cube. This is in the form x cube minus y cube. which is x minus y, in this case 15 minus 12, multiplied with x square, in this case 15 square, which is 225, plus xy, which is 15 into 12, that's 150 plus 30, that's 180, plus y square, in this case 144, 12 square. So this is 15 minus 12, that's 3, multiplied with 200, 300, 400, 480, 520, 540, 549. So this is 549. This is 1500 and 120. That's 1620 and 27. So this is 1647 centimeter cube. So if you reduce each edge by 20%, then the volume will reduce by 1647 centimeter cube. Good. Let's look at the next question. The next question that we'll do will be question number 8. Let's look at question number 8. Question number 8 says, solid metallic cuboid of this length, breadth and height is melted and recast into solid metal cubes of each edge 6 centimeter. So we have a big cuboid which is being broken up into smaller cuboid. So this is the big cuboid and this is the solid one, and this is being broken up into smaller ones. So each smaller ones, you are getting a smaller cube. What they want is how many such small cubes will be formed. So let's just figure out the total volume of the cuboid, figure out volume of one cube, and then divide. So let's just do this. So volume of metallic cuboid is equal to length into breadth into height. In this case, 72 into 30 into 75 centimeter cube. Next, volume of one metal cube. So each metal cube is of edge 6 centimeter, which means this will be 6 into 6 into 6 centimeter cube. So how many pieces would fit in, which is number of cubes would be equal to volume of metallic cuboid upon volume of one cube. Volume of one cube. In this case, 72 into 30 into 75 divided by 6 into 6 into 6. So this is 6, 1 and 12. This is 6, 1 and 2. This is 6, 1 and 5. So this is 5 into root 10, 10 into 75. That's 750 smaller cubes. We'll be able to make 750 smaller cubes from this big metallic cuboid. Done. The first part is done. Find number of cubes is done. We need to find the cost of polishing all cubes at the rate of 150 per square meter. So this is in meter. The number that we are working on right now in centimeter. So we will be polishing the surface area. Let's calculate the surface area. So total surface area of 750 cubes would be equal to 750 multiplied with surface area of 1 cube, which is 6L square. In this case, 6 into 6 into 6. That's the total surface area of 750 cubes in centimeter cube. Now we need to figure out the convert this into meter cube, which means no, not centimeter cube. This is centimeter square. My mistake. We've calculated area, not volume. So this is centimeter square, which is 750 into 6 into 6 into 6 upon 100 into 100 meter square. Yes, this is okay. Dividing it by converting centimeter square into meter square would be dividing it by 100 2 times. So 0 goes, 0 goes, 25 into 3, 25 into 4, 2 into 2, 2 into 3. And this is 2 into 5. Let's not do 2 into 5. This is 2 into 1, 2 into 3. So this is 27 into 6 upon 10 meter square. Let's not calculate it now. Let's see if we can avoid the calculation. Next step, it says 1 square meter costs rupees 150. So this much square meter will cost how much? So 1 square meter costs rupees 150. Therefore, 27 into 6 upon 10 will cost rupees 150 multiplied with 27 into 6 upon 10. This goes, which means 15 into 27 into 6. We'll have to calculate this. So 15 into 6, that's 90. So 27 into 9, that's 7 into 9, 63. 9 into 2, 18 plus 6, 24. So this is rupees 2,430. Done. So the cost of polishing all surfaces is rupees 2,430. Good. Let's look at the last question of this exercise that I'll work with you, which is question number 7. Very interesting question, both from the understanding and the exam perspective. You could put a big star on this question. Let's read the question. It's a rectangular tank of 30 centimeter, 20 centimeter by 12 centimeter contains water to a depth of 6 centimeter, which means this is my photograph 1 that's I've given for your reference. So in this case, this length is 6 centimeter. So there is a tank which is 30, 20 is the width and 12 is the height. Contains water up to a depth of 6 centimeter, which means the total height is 12, but it is being put in water. Water has been put in only till 6 centimeter. Next, a metal cube of size 10 centimeter is placed in the tank with its one face resting on the floor of the tank. So now this is the metal tank which has been placed here. This is length is 30, breadth is 20, the height is 12, and the cube is of 10 centimeter cube. So this is 10 centimeter here, 10 centimeter in width and 10 centimeter in height. So when this body is placed in, the water surface will rise up obviously. So what is the current level of water here? It is coming only till here. Next, they want us to figure out how much water we need to pour in so that the metal is submerged in water, which means they want the water level up to here. They want the water level up to here so that the metal tank is completely submerged. So how much water should be put in is what we need to figure out. Right? Interesting question. Water is still 6 centimeter now. They've put in some cube. The water volume obviously increases. How much more water should we put in so that the total metal cube is submerged? So let's figure out what is the volume of water required to submerge it, right? So volume of, not water, volume required, right? So volume required, because this volume will also include the volume of the cube. So volume required to submerge will be equal to the length into breadth into height. In this case, they wanted height up to 10. So this is length is 30. Breadth is 20 and the height is 10. This much volume is required to be filled. This is 3 into 2, 6, and this is 6,000 centimeter cube needs to be filled. This is the total centimeter cube that needs to be filled. How much water is already in the tank? So volume of water already in tank. It says it is filled up to 6 centimeter, which means the volume of water is 30 into 20, that's length into breadth, and the height is 6. So this much water is already in the tank. So this is 3 into 2, 6, 6 into 6, 36. So 3,600 centimeter cube of water is already in the tank. Is there anything else in the tank? Yes, the volume of cube is also in the tank, which means this is also occupying space. So volume of cube is equal to 10 cube, in this case 1000 centimeter cube. So how much water which needs to be added? That will be equal to the total required minus already in, right? So if this is the total volume required and this is already in the tank. So therefore volume of water to be added will be equal to total volume, which is 6,000, which is required, out of which 3,600 is already in there and 1,000 is already in there, which means 6,000 centimeter cube minus 4,600 centimeter cube, which is equal to 1,400 centimeter cube. Do they want the answer in specific unit? No, 1,400 centimeter cube. You can also give the answer in liters, which is 1.4 liters. Just a conversion reminder, 1,000 centimeter cube is equal to 1 liter and 1 meter cube is equal to 1,000 liters. Perfect. So that finishes this exercise for me. Couple of homework questions for you. Homework for you would be question number 9 and question number 10. Thank you so much. Take care. Be safe. Bye-bye. I'll see you with the next chapter.